All right, good morning. Taking a look at our next unit here. We're going to look at the mole. Got some music going in the background. I don't know if it's better or worse. Feel free to let me know what your thoughts are of the background music. All right, so today we're taking a look at 2.3. Moles. This is our third unit in chapter 2. It'll be our last unit. So this is the last bit of information we have before the test. The idea is mole, or I should say 1 mole, is equal to 6.02 times 10 to the 23rd, whatever. You could put any amount you want behind here, any unit you want behind here. And the mole is an amount. So it's really, really similar to dozen equaling 12. And say I have a dozen roses, and it's 12 roses, or a dozen eggs, or a dozen donuts. And same thing with the mole. You have a dozen, you have a mole of roses, and just be a gigantic number of roses. That's a really, really big number, 6.02 times 10 to the 23rd. Okay, so how do we use the mole? Well, here in the middle of the paper, box and put the mole in the middle of that box. Now, when you guys abbreviate mole, make sure you guys use MOL. You can't just use regular old M. That stands for meter. M's taken. MO is already taken. 20 elements is MO. So that's not much. You're not saving much time here just by dropping off the E. But the way we symbolize mole, MOL. All right. So over here, I'm gonna draw another box. It's gonna be a bigger box though. Box with representative particles. The first one we'll talk about, and we're probably all pretty familiar with at this point, is the atom. So an atom is a representative particle. Now I'm going to draw the box and we'll keep an extra couple lines here because we're going to add to that list of representative particles, or our others we talked about. And the way that we get from the mole to the representative particle, as we say, here's our number, 6.02 times 10 to the 23rd. I'm going to put RP. And I probably never see RP. It's not the abbreviation you use. There's atoms or whatever a representative particle is, but that's what that RP is standing for. That over 1 mole. So anytime you're trying to go this way, put your 6.02 times 10 to the 23rd particles, whatever they happen to be, over 1 mole. Let's say you have a number of particles and you want to get back to the mole. It's going to be reverse. 1 mole over 6.02 times 10 to the 23rd RP. And we're just using RP right now. Representative particles could be atoms, could be, we'll talk about other ones later. So that gets us into and out of the mole. A lot like a dozen does. If you have 48 eggs, how many dozen eggs do you have? Once you have the mole, then you can take it out and go to, oftentimes, mass. Now we'll go to other things later in the year, but for right now, we can go to mass. Now, the way that we do that is we use the periodic table, and we use the atomic number periodic table. Backwards, I'm going to change the arrows here. Sorry about that. Go this way if you want to go that way. So if you use the atomic number of the periodic table over 1 mole, that allows you to come this way. You're going to have your mass and figure out your number of moles. You'd say 1 mole. From our previous lessons, this big number here at the bottom, I almost always have a long decimal after it, 24.3050 for magnesium. That is the, not the atomic number, atomic mass. Excuse me. All right, that's much better. Okay, sorry about that. In the erasers didn't work out today. So the atomic mass is at 24.3050 for magnesium. And that's the average mass of, in this case, 1 mole of magnesium. All right, let's take a look at how we're going to go ahead and solve some of these problems here. First example. What is the mass? And they're asking for mass version in grams of 3.5 moles of copper. All right, well, we've had practice with this. Get your practice. They're asking what is the mass? We're going to put grams. We measure mass in grams. So that's what we're going to start with. Yes, I want to see that. It's worth half a point. And then what did they give us? In this case, they gave us 3.5 moles of copper. Now slow these problems down, guys. Don't be in any hurry. 3.5 moles. Don't just leave it at that. Yes, in the unit, you don't put moles, you lose a half a point. Just put moles. Put moles of what? Moles, in this case, Cu for copper. This is going to be really, really helpful later in the year when we start working with multiple types of moles. Moles of oxygen, moles of iron, moles of rust that come together to form rust. Well, you don't label what your moles are of. Going to end up confusing yourself. Okay, so I know that moles of copper has to go on the bottom. How do I know that? I need to cancel out. Whatever the unit is here, that's the I want to have on the bottom of my next step. Moles of copper divided by moles of copper is going to cancel moles of copper out. Our next question is, can I go directly from moles of copper to grams of copper? Look up here, and yeah, that's a one-step process. What we're going to need is the atomic mass of the periodic table. So get that out again. Gotta find copper on here. There it is, kind of right in the middle, number 29. Mass there is 63.546. That right here, 63.546 grams of copper per mole of copper. And hey, there we go. Moles of copper has canceled out. What we have left is grams of copper. That's a little bit of crunching of the numbers, 3.5 times, and multiply numbers on top. Divider on the bottom, we can ignore the ones. So 3.5 times 63.546. Grams of copper. This value here only has 3 significant figures. This one has 5. It's multiplication steps. We're going to take just 3. So that's going to be the 2, the 2, and the 2. So our final answer, extra digits. So I underline my extras up here. I don't want it in the final answer though. 122 grams of copper is the mass. 3.5 moles of copper. Next example, let's work with some atoms. So how many moles are there in 1.20 times 10 to the 19th atoms of silver? All right, guys, we're going to set this problem up the exact same way. What am I looking for? Question mark. How many moles of silver? The atomic symbol for silver is Ag. And that's equal to 1.20 times 10 to the 19th atoms of Ag. And again, all I have done at this point is restate the problem, and I've got 1.5 points if I'm taking the test just for restating what the question is. Now I know that atoms of silver goes on the bottom. Why do I know that? Because atoms needs to cancel out. Top here, it's going to have to go on the bottom here. So the next step is I'm looking for moles. Can I do this in one step? Here I have atoms. Yeah, that's just one step. One top. 6.02 of my representative particles. Bottom. So 6.02 atoms is 1 mole of silver. And that 1 mole, it's kind of like saying 1 dozen silver is 12 atoms of silver. So 1 mole is 6.02. It's the same concept. It's a much larger number than a dozen. Once again, we're ready to compute. Today, watch how I'm throwing these numbers in my calculator here. For this 1.20, I'm going to put 1.20 second, big E, 19. You can all see that on my calculator. I don't hit the times 10. I don't have a caret symbol, none of that. I just hit 1.20, big E 19. Now we have the number on the bottom, so I'm going to divide 6.02, second big E, 23. There we go. And you guys can see how I'm entering these numbers. I'll do that. I don't have to worry about order of operations. It's taken care of. Hopefully you guys are getting the same value. If not, you want to come talk to me. Let's make sure we get your guys' calculators working properly. So 3 significant digits again, 3 significant digits here. Many atoms that we had a lot. That is a lot of atoms. It's still just a fraction, a very small fraction of a mole. Write this either way. There's your standard notation, or you're more than welcome to make it scientific notation. Either way, perfectly acceptable. Another one, how many grams of copper are present in 3.01 times 10 to the 23rd atoms of copper? Okay, one more time, we're going to set this up. Question grams of copper. So that's what we're looking for. How many grams of copper are equal to, what did they give us? One times 10 to the 23rd atoms of copper. Okay, so again, I know that my unit on bottom here needs to be atoms copper. How do I know that? Because I know it needs to cancel out with the unit right here. So atoms copper divided by atoms copper. We get atoms copper to cancel out, we won't have it any longer. I have atoms. In this particular problem, we're looking for grams. We're going to need to make 2 steps. It's not going to be a single step problem. It's going to take 2 steps. We're going to get the mole first. We'll get to grams. So first step, 1 mole of copper has 6.02 times 10 to the 23rd atoms of copper. Next step, and I'm kind of out of room up here, so I'm going to come down below. Continue my problem. There's never a problem doing that. So atoms of copper is canceled out. Now I have moles of copper. So I know down here, moles of copper goes to the bottom. Let's take a look if this helps. We have moles. We're trying to get to the mass. I want moles on bottom. I just put that. I want the atomic mass off the periodic table on top. So bring back out that periodic table. I know we just found it, but my memory's not so good. There's our atomic mass of copper. (63.546 grams of copper in 1 mole of copper. All right, so practice entering this in your calculator again. We've got 3.0 big E 23 divided by 6.02 second big E 23. And we don't have to worry about that one. If you really want to, you can plug that times 1 in there. It is on the top, but it's identity property, right? You don't have to worry about it so much. 3.01 times 10 to the 23rd divided by 6.02 times 10 to the 23rd times, come back down here, this number's on the top, 63.546. And there we go. The moles of copper has canceled out. Take a look at our significant digits. Got 3 there, 3 there, and a whole bunch more than 3 there. We're only going to have 3 in our answer. I'm going to round the 7 up. 31.8. So there we go. There we go. How much a whole bunch of atoms of copper weighs. Now take a look at some other representative particles then. So oftentimes work with atoms, molecules. Now be careful when you shorthand molecules. You can't use MOL. You can't use MOLE. It just is the mole. So we'll symbolize the molecule. You see MOLC on it. Shorthand molecule. We also have the formula unit. Symbolize that as for U. And you're sometimes even going to have ions. For ions, specifically, like let's say you have K2O. Well, K2O has 2K ions and 1 oxygen ion. And I have to look at the chemical formula working with ions. So you might see a lot of these different representative particles as you're working. Be thrown off, they all work the same way. 1 mole of any of them. 6.02 10 to the 23rd. One more example like that. This one's going to be a long one. Calcium nitrate, CaNO3, 2. That's what the question is working on now. Again, it's going to start off the exact same way. Even if you get this question on a test, you have no idea what to do with it, you get some point, you just want to start know how many oxygens, question mark, oxygen, for oxygen, is equal to 6.00 grams. Calcium nitrate. At this point, all we've done is restate the question. Got a point and a half. All right, so I know that grams, I'll leave myself some room, grams calcium nitrate is going on the bottom. And how do I know that? Because I need to get this unit to cancel out. Back the little chart here, I have grams of something. Pretty much the only place I can go is to moles. In order to do that, I'm going to do atomic mass. And here's the confusing part about calcium nitrate, is we're going to have to figure out the atomic mass. I'm not just given it. So, calcium, 40.078. One of those. Calcium. I'm going to add to that my number of nitrogen. Take a look. It's kind of like algebra. Everything inside the parentheses is multiplied by the 2 or whatever number it is outside the parentheses. So I've got 1 nitrogen inside of it times 2. So I've got 2 nitrogen. Again, minus the periodic table. Find nitrogen. 14.00674 grams up the table. And then finally, the third element here, oxygen. To keep in mind, take a look at that. That 2 outside the parentheses applies to everything within. And I have 3 oxygen inside. That's 6 oxygen. Find oxygen. Table inside. Now we're ready to go now. 40.078, but multiplying plus 2 times 14.00674 plus 15 plus 15. I'm not sure anyway. 6 times 15.994. There is our mass of calcium nitrate. Check, make sure you guys got the same values there. I know something we want to make sure that we do. Significant digits. This one, again, it's an addition problem this time. We added these guys all up. This one here goes 3 places past the decimal. This one goes 5. This one goes 4 places past the decimal. We're going to be limited to just 3 places past the decimal. That's 0, 8, and 7. These 2 8s are not significant. No reason to round them. I just need to underline them to show that they're not significant. Same thing up here with the underline. And again, that's my grams per mole calcium nitrate. Hey, fantastic. Got a little extra work there. But we were able to knock out grams of calcium nitrate. Moles of calcium nitrate next. So again, I'm going to start off on the bottom here. 1 mole of calcium nitrate is 6.02 times 10 to the 23rd. Calcium nitrate. Technically, we'd say 4 milliunits, but we're just going to write calcium nitrate here. So there are 6.02 times 10 to the 23rd of these in every single mole. Final step, yes, we're finally there. The final step. We're not just looking for calcium nitrate, we're looking for number of oxygen. There's 6 oxygen in every 1 calcium nitrate. 1 calcium nitrate, 6 oxygen. All right, there we go. Quite the problem, but moles have canceled out. Calcium nitrate is canceled out. We're left with just oxygen. That's what we're looking for. Fantastic. We are ready to solve this problem. 0, 0 divided by, it's on the bottom. 0.8788. Times, so now we're back to the top, 6.02 second 23. Hey, we're getting familiar with that number quickly, aren't we? Times 6, because it's on the top. Press our enter button. And there we go. Let's double check significant digits. 3, 3. And well, there's a whole bunch more than 3. I'm writing 3 to my final answer. 1, 3, and 2. Don't forget about the exponent there. 1.32 times 10 to the 23rd oxygen particles. We found 6 grams of calcium nitrate. All right, well, this is fantastic. Yes, if we wanted to, we could work this backwards now. Now that we have our number of oxygen, we know our mass of oxygen, our mass per mole, we could work backwards and figure out what mass of oxygen we have. We we know we have 6 total grams. Really wanted to take this backwards and figure out of that 6 grams, how much is oxygen. We're not going to, at least not for this video. Something you're curious in, looking at these pathway periods, something we're taking a look at. So hopefully this helped with the mole. Good introduction. You got plenty of homework. You have to do homework to learn this stuff. Absolutely about the practice. So give it a shot, and we'll see you guys next time.